Okay, so we have this quiz. The number a to the -2. Everybody got different numbers for a. If you have the 7 to the -2, well, that's 1/7 squared. 1/49. Now that's the rule that you need what a negative exponent is to understand the basic exponential function. Okay. So I'm not sure whether that was on the homework or not. Kind of think it was, but I don't know if the negative exponents were there. We revisit negative exponents again a little bit later. But that's something that you should know from having done everything that you need to have done on the basic exponential function. Okay. So that's where you get the negative exponents. And I need to see that written out. I didn't put it on the quiz today, but I can put any of the basic functions on a quiz anytime. You always have to be able to do them quickly. So if you are still unsure about the arithmetic on those tables, you really need to be very sure. Okay? You need to be able to show me the arithmetic, including the negative exponents. And ultimately, you need to understand what they're telling you. Okay? Okay, 1/p² to the -3 means what? It means 1 to the -3 over p² raised to the -3. Okay? What's p² raised to the -3? We'll put 3 dots down here. I'll work that out. Or have a little more room. Okay. Now, another one, and I said this could be a little bit of a curveball. I warned you about that, right? And still, many of you just got way into arithmetic, so heed warnings. Okay. I gave you time to do it, but you know, heed the warning. If I say it's a little bit of a curveball, then there's a curveball then. I'm not sure how to do it. I better move on. Right? And for quizzes, it is important to know when you can do something quickly and when you can't. Looking at these, you can identify everything here can be done very quickly, except for this. Now, if you know the rule, then you might not know this. I don't know if this was in the homework or not. Okay? It's something you're supposed to know anyway. So I put it on there. You know, you can then go ahead and take the 4th power of 7 and the 4th power of 11 if you're up to it. It's unnecessary because the square root, and you want to store this away. It's important later. Might as well store it away now, so at least it'll be familiar to you later. This is 1/2 power. So 7/11 to the 1/2 power raised to the 4th power, which is you take a power of a power, you multiply the powers. You should understand why. That was explained. Should be able to explain that. I didn't ask you to explain it. But it's going to be important. It's important in your pre-calculus class. Okay? Got to know these things. So we want to look at them right now. Just because we haven't gone into detail on negative exponents in the meaning of a square root, you know, what power is that? That doesn't mean that your pre-calculus class isn't going to assume that you know it. Okay? And doesn't mean it won't mess you up. Anyhow, 1/2 times 4 is 2. And it's easy to square 7 and square 11, right? Much easier than taking the 4th power of 11 and the 4th power of 7. I know the third power side is 343, so I can pretty easily calculate the fourth power, but I don't remember what the fourth power is. No reason you should either. That comes out 49 over 121. Makes me a little nervous. The screen freezes every once in a while. But it doesn't seem to affect it. Okay. So again, key here to avoiding half hour's worth of calculation is, and then, yeah, you did well with the calculation. That's good. That's pretty good, but not necessary here. Okay. Use the laws of exponents because that was your assignment, right? Okay. XY squared to the third. Now, I really want to see you write out steps. If you write out x to the third, y to the sixth, well, I kind of know what you did. But if you write out x to the third, y to the 12th, I want to see what you were thinking. Okay. I want to see whether you were applying the laws of exponents. If you make a mistake, it's particularly important to write out the steps so I can tell where these things are. Then I can be helpful. Well, sometimes mistakes in algebra is one like the add instead of multiply. Okay, it's easy to do that. So if you do that, if you got x cubed y to the fifth, I know what you did. But if you get something a little off the wall, so you want to write this out as x cubed y squared cubed. Just how you made mistakes on this one. You didn't write out the steps. Also, if you write out the steps, you're much less likely to make a mistake. If you know the rules, which I think you do. Because I saw people doing it right here, and making a mistake here. Okay. I'd even go so far as to write x cubed times y to the 2 times 3, because that shows that you know that when you do a power of a power, you multiply. Of course, if you write out y to the 6, I know you multiply it, so I suspect that you know it. But you write it out so you reinforce it. It just takes 3 seconds to write out x times y, x squared times y to the 2 times 3. And that goes into your brain better than if you just do it in your head, write it down and forget what you did. Okay? So that's x cubed y to the 6th. Now xy squared over z cubed quantity squared is x squared y squared squared over z cubed squared, right? There's even another step I could write. I don't have room, and I'm kind of okay if you skip that one, because I don't think you're going to make any mistakes. But be careful. No, I could have written this as quantity xy squared squared before I wrote x squared y squared squared, right? Okay. Not a bad idea to do that, but anyhow, you get x squared then y to the 4th over z to the 6th. Okay. So, big deal. Understand what the radical means. Okay, somebody had the 11 outside the square root. I might use maybe should have. I think I wrote that wrong enough. Put it on low. Okay. But if you did, you could just start taking 11 to the 4th power. Now down here, y proportional to x. What does it mean for y to be proportional to x? It means that y equals AX. Now that's very straightforward. You know, many of you got it, some of you didn't. Okay. That kind of depends whether you did that part of the homework or not. And this is really easy stuff. you really want to get this down because it's not, in addition to being easy, it's really important. Be able to think in terms of proportions gives you a set of tools that you use a lot in many courses, many curricula. An important insight, important mathematical insight. So y equals kx. Now, y equals g when x equals a. So you take that. Let's say that g is 19. And a is 5. If g is 19 and a is 5, then y equals kx becomes 19 equals a times 5. So, I think everybody can solve that equation. Okay. So let's get the step of dividing both sides by 5. Yeah. Okay. 19 over 5. That y equals kx becomes y equals 19 over 5 times x. And now, if f equals 14, then of course x equals f, so x is 14. So that y equals 19 fifths. Multiplied by 14. Yeah, well, 19 times 14 is 190, plus 76, which is 266, I think. And of course, 20 times 14 is 280, and you subtract 14, you get 19 times 14, and that gives you 266. I just double checked this. I think you may be right. Okay. That's the process. That's how you solve every problem with the direct proportionality. They also have inverse proportionalities. I think that was in the homework. Maybe even a proportionality to the square, but if you understand this, you can understand those others. The process is just very similar. Just your equation might be y equals k over x. But if it says something is proportional to something, then that something equals k times the other something. And you just immediately write that down. Then you put your information in. Hopefully you have enough information you can solve for k. Then you rewrite this y equals kx in terms of k. And plug in whatever other information you have, and you get a solution. Okay? And it's always the same. Interpretation might differ, but the process is always the same. So all you got to do is practice it a few times and remember it, at least well enough so you look it up again and say, oh yeah, that's what we did. Okay. Okay. So as I just said, People didn't do as well on the homework as due today by equation to a straight line than on the others. So I didn't go over that, because I figured it was something you would pretty well know from your prerequisite courses, but apparently I should have gone over it. So let's go over it. So equation of straight line. The slope-intercept form M is the slope, U is the Y-intercept. Okay. So I'm going to ask you if you would write down the equation, or if you can write down the equation of a straight line. To the points 0, 3, and 7, 6. Okay. Now, almost everything you have here, well, you have almost everything. Well, you have the Y-intercept. The Y-intercept is a point where the Y coordinate is the point where the graph goes through the Y-axis. So Y-intercept is 3, so we know what B is. B equals 3 since the Y-intercept is 3. Now all we do have to do is find the slope, and then we write 3 here, and we write whatever the slope is here, and we write that as the equation of the line. And then we have a formula that allows us to determine the point on the line for any value of x. Or we can determine the value of x for any given value of y. We'll see how that works. And we talked about fundamental triangles on Thursday, didn't we? Yeah. And I knew I'd done that in one class, and this is the only class I logically would have. But it's easy to make up these classes, especially in my case. Okay, so here's your fundamental triangle. The run is 6 minus 0, which is 6. And the rise equal, you know, you're looking at me like I'm nuts, and that's probably true. Looking at numbers and writing them down without thinking about what they mean. I pretended to do that, so I would illustrate something that people often do, right? I didn't really do that. Okay, you can believe what you want to believe. I know, I've got my story. Okay, anyhow, your run is 7 minus 0. And your rise is 6 minus 3. Because of course you're going from y equals 6, y equals 3 up to y equals 6. Slope is rise divided by run, which equals 3 over 7. Well, now I've got my slope and I've got my y-intercept. What am I going to do with them? Slope right here goes here. The y-intercept 3 goes here. What do we get? Slope goes here. Yeah, 3/7 x plus 3 x could be x. And it's less time here, make it wide open, self-blocking out the code. Okay. I apologize for getting moved down. Really part of it is the mask keeps blocking what I'm looking at. I have that in my brain in there. Okay. Okay, so there's this, there's the equation. What good is the equation? Well, let me ask you to do this. Okay. As we do, want to get used to what it means to solve these equations. Okay. If x equals 2, you have this equation, y equals 3/7 x plus 3. There's your equation. What if x equals 2? Then y is 3/7 of 2 plus 3. So y 3/7 times 2/1 plus 3. Which is 6/7 plus 3. And that's 6/7 plus 3/1. Of course, you have to have a common denominator here, so you've got to multiply by 7/7. So 6/7 plus 21/7 or 28/7. 27/7. That's a little bit less than 4. So if x equals 2 on the graph, well, here's x equals 7. So that's the coordinate of this point. So where's 2? Well, 2 would be about here. If you look at the graph, the point on the graph corresponding to x equals 2 is here. And that point projects over to the y coordinate here. Now, if the y coordinate of this point is 3, it makes good sense that the y coordinate of this point is close to 4, right? Now, 28/7 would be 4, 27/7 is a little less than 4. So it makes perfect sense in terms of the graph. Now, you have to understand this picture, that you could estimate this. If x equals 2, you just go up to the graph and over and see what y is. And that agrees with what the equation tells you. Okay. Now, we said if y equals 9, what does x equal? Well, 9 would be up here, here, here. So you'd have to take the graph way up here. Looks like x come down here, be about maybe 16. Okay. In other words, if 9 on the y-axis is way up here, if this equation or the line is extended, it goes maybe to about here, actually goes a little further. 9 here, comes out to here, and that might even be between 15 and 20 somewhere. Well, we can take the equation and figure out what it is. Now that we have a picture, a graph that gives us the information, that gives us a good idea what y ought to be, or what x ought to be. So, over here, if y equals 9, then 9 equals 3/7 of x plus 3. We multiply both sides of this equation by 7. And multiply this, and this by 7. And we get 63 equals 3x plus 21. So that 63 minus 21 equals 3x plus 21 minus 21. Meaning that 42 equals 3x. We divide both sides by 3. And we find that x is 14. I said it may be between 16 and 20. Well, only went out to 14. But you get the idea. The idea is, once you have the equation, if you know what x is, you can find y. And if you know what y is, you can find x. You've got to be able to solve the equations. So I'm going to look back at everything we've done, make sure that you're in good shape for solving equations, linear equations at least. Okay, we want to find the equation of a line through the points 2, 4, and 7, 12. First thing we do is sketch the points. If you don't have a picture, you don't have the picture. Okay? If you're just using formulas, it's not going to mean much to you if you don't relate it to the picture. So, maybe the line is like this. Now it's a freehand line. I can estimate what the y-intercept is. It might be about 1, right? But it's not that carefully sketched. That's probably not completely accurate. One thing that we can do is we can find the slope. And without going into a lot of detail in the estimation, the run is 7 minus 2 is 5. Rise is 12 minus 3, which is 9. So the slope, rise over run, is 9/5. That's right over, that's 9/5. Plug the slope into the equation y equals mx plus b. You get y equals 9/5 plus b. Looks like that's okay. We'll do it. Okay. Now, plug the values of x and y into the equation. Using either point. Okay, well. Using a point with the smaller numbers, because often it's easier to work with smaller numbers, although it doesn't make a big difference. Using the point 2, 4, we see that x is 2, y is 4. So 4 is going to be y. X is going to be 2. Okay. Solve for b. Well, we multiply both sides by 5. We multiply 5 times 4 plus 5 times 9/5 times 2 plus b. Plus positive. So everything, 4 has been multiplied by 5, your 9/5 of 2 is multiplied by 5, your b is multiplied by 5. Why do we do that? Because you multiply 5 times 9/5, well, that's 5 over 1 times 9 over 5, and so forth. And keep talking about that. But 5 times 9/5 is just 9. Multiply that by 2, an equal sign, plus sign. We subtract 18 from both sides. And we see that b equals 2. Now, with my sketch, I estimated that b would be 1, but the y-intercept would be 1. So I told you that was a little bit iffy. Yeah, we got a question here, so it appears that I might have done something wrong. Oh man. Oh, I stopped it because I recorded most of that. Okay, so we had an objection there. The point is 2, 4. I should have done 12 minus 4, which would give me 8, right? Instead of going through all this and correcting it, I just changed the point to 2, 3. That it works, except the picture doesn't work so well anymore. Still, there you have it. And this is the procedure. Sketch the points. You got 2 points, sketch them. Does it mean something? And you'll remember it better. Find the slope. Sketch the triangle and do it. Don't rely on a formula. Then use the formula. Check yourself. Okay. I could have used that. If I'd used the formula, I'd have used this point and this point as I originally had it. And I would have seen that, oh yeah, no, I didn't see that. Okay. I went by the coordinate down here and messed it up. Okay, plug the slope into the equation. So here's the slope, we'll plug it in. Plug the values of x and y into the equation. We could use either point. but I use this point, it would have come out with the same result. And we solve that for B, because once you've plugged in X and Y, you've got numbers here and here. The only thing that you don't have is the value of B. Then you use equation solving techniques to solve the equation. The important equation solving technique is if you've got a denominator anywhere in the equation, multiply both sides of the equation by that denominator. If you understand the fractions and you need to, that denominator goes away and you have a nice equation that you can easily solve. Okay? It's just the whole number, integer coefficients. So there it is. So now you write out the equation. In this case, 9/5 x, the 9/5 coming as a slope, and the value of b being y-intercept is 2. Okay.